Okay, for 28, we're going to use a little trigonometry to solve this triangle. All right, so what we have, if this is our reference angle, that would make y the opposite side, and 7 the adjacent leg. So we have adjacent leg, opposite leg. So we're going to look at our SOHCAHTOA, and the function that uses opposite and adjacent would be tangent. So this is going to be a tangent problem. Tangent of 64 degrees equals the opposite over the adjacent. So now it's just basically a fraction. We're going to get rid of the denominator, so I'll multiply both sides by 7. So y will equal whatever 7 times the tangent of 64 degrees is. And that is going to be about 14.35, we'll call it. Now for x, that's going to be our hypotenuse. So now I know the adjacent, and I need to find the hypotenuse. So if I look at SOHCAHTOA, the function that uses adjacent and hypotenuse would be cosine. So now this would be the cosine of 64 degrees equals 7 over x. Basically, in this problem, if we multiply both sides by x and divide both sides by 64, that's how we're going to get x by itself. Some classes have seen a shortcut where they can go from that initial setup to x equals 7 over cosine of 64 degrees. We're going to type that one in. And we're going to get about 15.9697. 15.97. For the second problem, for 29, I need to find this missing side first. Well, if I have two sides of a right triangle, I could use Pythagorean theorem. I don't need trig to solve that problem. So if c squared equals 74, take the square root. And the square root of 74 is going to give me about 8.6. Now for angle A or angle B, I can pick either one that I want to find first. It really doesn't matter. So if I pick A, I'm going to label the two sides I have. I'm going to label 5 the opposite leg, and it would make 7 the adjacent leg. So on a function where I have opposite and adjacent, that's going to be tangent. So this would be the tangent of angle A equals 5 over 7. Now if I want tangent to go away, to find that missing angle, I'm going to use inverse. So A is going to be tangent inverse of 5 over 7. I go back to my trusty calculator here and go tangent inverse. Remember, the tangent inverse will get you an angle. So that's going to get me about 35.5 for angle A. Now, at this point, I have two of the angles of the triangle, so I can just subtract those two angles from 180. Even faster than that, if it's a right triangle, the two acute angles are complementary, so if I subtract that there, you're going to get 54.5. That's a good answer because 54.5 is across from a side that's 7. And 35.5 is across from a side that's 10. So the larger angle is across from the larger side. Shorter side is opposite a smaller angle.